So my name is Jorge. I am from Puerto Rico. Even when my seminar is uh, fundamentally on renewable energy schemes, it is really on the relations between our planet and our star, the sun, and how our star, the sun, by interacting with us through the emission of energy, actually have been an important fact in the availability of food, in the problem with the greenhouse gases, and therefore in overpopulation. So actually all the life-threatening problems in our planet can be related to the sun in some ways. So we would like to start by mentioning that the sun originally was just a big nebula, fundamentally of hydrogen, and when the hydrogen get together by gravitational interactions, so somehow in that cloud of hydrogen, there was a fluctuation where the density became larger than the rest and start attracting towards the center of that highly dense nuclei, start attracting more and more hydrogen until it became a huge ball of hydrogen, but at the center the pressure was very high, the temperature was very high, and nucleosynthesis started. So for example, most of the radiation that we receive on Earth is the result of hydrogen atoms combined to form helium. Of course, that's something that we have been trying on Earth to reproduce to no avail. It has been a tremendous challenge. So it requires a great deal of external inputs of energy. But nevertheless, we all remember Einstein relation that the energy is equal to the mass times the velocity of the light square. So the mass of the two hydrogens, it was a little larger than the mass of helium. And that difference in energy, that difference in mass became energy, and it gets irradiated as a form of electromagnetic radiation. And it was incident on Earth. It was incident on Earth fundamentally due to the plane of the ecliptic. That is the plane where all the planets, well, most of the planets lie. Due to that relation, that radiation, it's incident between the two tropics, the tropics of Cancer and the Tropic of Capricorn. And all that tropical belt around the world receive a great deal of that radiation. And what we will study in the seminar is how that radiation is important in all the forms of energy that we have on Earth. The basic form has been through photosynthesis. So the radiation from the sun, it's utilized by the development through millions of years of plant life to take CO2 and take water and the radiation from the sun and form some simple sugars and oxygen that all the rest of the living beings on Earth rely on it for its very existence. So all the plants take all that energy and synthesize sugars. Those plants eventually die. Plants fall on top of plants. There are tectonic global phenomena that place large amounts of mineral matter on top of it. It gets buried, and fossil fuels are generated. They are fossil fuels because they used to be alive once upon a time. They used to be plant alive. And now we have all this carbon, and we have all this petroleum, all this natural gas. And it happens in Great Britain at some point in their development that they enter into the discovery of how to utilize heat in order to boil water and form steam, and how the steam can generate a great deal of pressure, and you can obtain mechanical energy. So energy is the capacity to do work. We can obtain work done by a mechanical entity from the generation of heat. And unfortunately, to generate heat, you have to burn something. You have to burn wood, or you have to burn carbon, or one of the fossil fuels. And of course, with the consequential generation of all the greenhouse gases, at least some of the greenhouse gases, the one in the largest amount that are really controlling. They're one of the great problems worldwide with us. So we would like to look at how we can somehow substitute the burning of things, the oxidation, the combustion, to generate heat, and only heat as the source of energy by doing the utilization of energy directly. And that can happen because between those two tropics, the Capricorn and Cancer, the amount of energy received from the sun, and actually more than the amount of energy, because early in the morning, the sun, it's very light. We can hardly feel it, but at noon, when it is in the zenith, it really can burn our skin if we are unprotected. And of course, it's a periodic phenomena. So it's power. It's how quickly we receive energy, how quickly we can do work. And the power received in most of the area around the equator, between the two tropics, it's about 1 kilowatt per square meter. So in 1 square meter, we receive 1 kilowatt of power. It's interesting because a typical house in North America and perhaps in Europe will consume of the instantaneously, it's energy per unit time, about 20 kilowatts. So we have a tremendous amount of power being received by the earth that it's really begging for being utilized as a source of energy rather than using the fossil fuels, burning and generating greenhouse gases. So we will explore. My usual technique in the classroom is to present the material, discuss it, do as examples example problems, trying to make it as quantitative as possible because data is really, really important. And then seeing how we can relate different aspects of the development so we can really understand the development of it. We will study how we can use the radiation from the sun directly through photovoltaic. Those are solar cells. Solar cells, it happens that among the 3 or 4 renewable energy schemes, namely solar cells or aeolics or wind mills, or low-head hydroelectrics or hydroelectrics in general, or biomass. There's people who actually plant large extensions of land with elephant grass that is an herbaceous that produce a tremendous amount of combustible material, and that it's sort of in some ways carbon neutral because you're planting and then you are burning it and then you're planting. So you're actually consuming the carbon that you're going to liberate later on. But nevertheless, all the 3 fundamentals, photovoltaic and wind and water, are the result of what happened with the sun. The sun, when it's incident in the equator or in the area between the 2 tropics, hit the water. Most of the surface, it's ocean, hits the water reaches a certain temperature with some vapor pressure. It goes into the gas phase heat up, reduces its density, keeps on going up, but the Earth is moving like a spinning top. And therefore that introduce some forces into that gaseous mass, move it into the 2 poles, the North Pole and the South Pole, and all the big land masses. And that is what produces the wind, that it is utilized for aeolics generation of power by moving windmills. And the windmills are moved, and people have developed a sense of how to do it for centuries. But right now it's a science. The cross section of one of the blades of the windmill, it's like an airplane. So there's lift, and you can really make something that transduce, that change energy of motion of the wind into electrical energy that can be utilized later on. The same thing happened with moisture. Moisture is evaporated from the surface of the oceans. It goes into the atmosphere. It goes into the 2 ends of the globe. It's mixed with particles. The nucleates in the particles form raindrops. It rains. It fell into the rivers and lakes, and we can obtain the energy of motion and also the gravitational energy, the energy due to the mass of all that water moving and converted into electrical energy. So all we are doing is fundamentally utilizing our relation with the sun, and the people who speculate in the possibility that there is another planet or another place in the universe where there is life, that if they are smart enough, they probably quantify their relation with respect to energy by the amount of energy that they extract from their own sun, from their own star. Of course, that's beautiful for science fiction, but nevertheless, it's really important for us, and we should take it into consideration, teach it to our students, see if we can stimulate them to read about it, to participate in scientific fairs, to show people that this is the best way of doing business, and try to avoid all the consequences that we are all deeply familiar of combustion and the utilization of fossil fuels. So we will discuss the material, we will discuss the problems as examples, problems as exercises, and then we will discuss the design. Design, it's really important. That is what it's going to drive them into the interface between science and technology. Thank you kindly.